Hi everyone. In this video, fractional knapsack problem is discussed, which is a classic problem of greedy algorithm philosophy. As the name implies, fractional knapsack means there is a division of the items. So let's say knapsack is nothing, it's like a bag in which we would be accommodating some items, and each item has two things, the weight and the corresponding value. Okay, so let's say I have four objects inside my bag, and four objects would have its own weight and its own value. Okay, this is object A, B, C, D, weights of A, B, C, D, and weights of A, B, C, values of A, B, C, D. Okay, so the maximum capacity a bag could hold up is 50, assuming this is the maximum capacity. Now, as per the problem statement, what we really have to do is I want to fill my bag with these selected items from the list of items in such a manner that maximum value could be attained. Okay, so two things you need to solve for this. One, value should be maximum. Second, whatever items you're taking up, weight should not exceed the capacity. Weight should not exceed the capacity. These two things you have to follow. Means either you can take the full item or you can take a fraction of it. As it is fractional, which means there is a division among the items. If it is not possible to take the full item or entire object, we can put a portion of it in the knapsack. Okay, this is the theory. Now let's say, given this input, what would be the corresponding output of it? For example, if I say the corresponding output of it is 250, which means maximum value or maximum profit which could be attained is 240. Now, several hit and trial would be performed on this, and out of this, maximum profit would be the final answer. Now, how is it happening? Let's say I decided to pick the first element, first item, I should say. Okay, so first item weight is 60 and the corresponding value of that item is 60. So weight is 10 and 60. Okay, so I would be taking this as, let's say I have taken up the 60, and remaining capacity, how much I would be left with is 50. Since I have taken 60, so I would really subtract the remaining capacity, okay, which means 50 minus 10, which means I am left with 40. So I need to make up this 40. Okay, now this is done, this is done. Okay, next time I have again decided to take up the whole object. Okay, now again the whole object means let's say this time I decided to take up 20. Okay, and the corresponding value would be 100. So here total value would be 60 plus 100 and weight is 20. Again 40 minus 20, we would be left with the 20 as the remaining capacity. Okay, so here the total value so far is 160. Okay, now you have to think about it really smart over here is, so first, I mean this first and third, this is completed. We are left with 40 and 30 and here 40 and 120. Okay, now if I'm planning to take up my whole object, let's say 40, right? And if I'm planning to add 40 to it, it would result me 200, right? Which is less than the required profit or the maximum profit. So it's not a good idea to take up 40. Okay, even if we are planning to take up 30, 30 will also not be able to attain the required profit, which means I have to take a portion of it. Now, definitely 40 will not be helpful to us in any manner because the maximum profit I am getting is 200, which is less than the output. So, I have decided to take up the 30. Okay. Now, definitely, I cannot take up whole because it would exceed the capacity, right? Not capacity. Yeah, definitely it would be exceeding the capacity because the remaining capacity we're left with is 20 and it is 30, which is just the less, right? So for this, I would be taking a fraction of it, right? So there is a formula to take the fraction. Let me call it ratio. So ratio equal to value by weight into remaining capacity. So what is the value? Value is 120 divided by weight, which is 30, into remaining capacity. How much we are left with is 20. Okay. So this is basically resulting out to be 80. Okay. So we already had 160 and then we add 80 to it. It will result me 240. Okay. Which is the required output. So this is how we have done. For the first two time, we have taken the full object, and for the last time, we have taken a portion of it, or ratio of it, or a fraction of it. Okay, so we need to find out the maximum profit which could be generated by some hidden trials so that we can get the final output. So, with this logic, how to come up with the solutioning of it? That should be my main target, right? So, can I say that I have two cases, case 1 and case 2? Okay, case 1 means whole object I am taking or whole item I am taking. Okay, case 2 means fraction of item. Okay, so this would be my two approaches, right? And definitely, I would always be picking up my highest object first, right? Because we have to be very greedy with this. Since we are discussing about greedy algorithm, that means what? We have to sort the items in the descending order of the ratio so that items would with greater ratio would be picked before the items with a comparatively smaller ratio. Okay, and while picking of the item, it might be possible that we are taking the whole object or we are taking the fraction of it, whatever it is. So, first step would be always to sort. So, before case 1 and case 2, I should write the common thing which is to sort. I would be sorting my items based on a ratio. Okay, once I have done this, what I would be doing, this is the first. Second would be to run a loop. Definitely, I would be running a loop entirely from scratch till the end, which means if I have items, I would be running a loop from 0 to till the length. Okay. Now, in case if you're planning to take up the whole object, then what we have to do is, let's say I have a dummy variable which is result. So result is initially 0, which means nothing I do have now. Okay. If I would be taking my full element, then I would be adding value to my result, right? So result plus equal to value of I, correct? I'm adding this, right? So we have to take care of two things, weight and value. Value is sorted, right? And what will happen to the weight? As we have seen that if we are taking or considering the full whole item, then I would be appending the value into my one resultant array. And then in the second step, we would be subtracting the corresponding weight associated with it, right? So capacity would be what? Capacity minus equal to weight, correct? So that we can find out the remaining capacity. Yes, this is what we have done. In the first scenario, we have to add the value and then we have to subtract the remaining capacity. Otherwise, case 2 means what? We would be adding the portion of it. Of course, we have to add the portion of it. That means I would be adding what I would be adding into my resultant array. It would be fraction of it, which means ratio into The remaining capacity, of course. Correct. So this would be the one, right? And then again, I would be doing the same thing. I would be subtracting the remaining capacity would be again subtracted, right? Minus equal to the Wi. Or you can also say that remaining capacity would be zero because at the end of the day, my full capacity would be exhausted. So I would not be left with anything. Correct. So I can clearly make my capacity as zero. That could be the other way around. So this is how we are gonna solve this problem. Okay. Now let's get started. I would be coding with Java. So for sorting, definitely I would be using this concept of comparator. And for storing the details of the item, I would be using class. Okay. So let's say I have item. Item is nothing, it's just the element. And here it has two things. I think it should have three things. Okay. Firstly, it should be my weight. And then it should be my value corresponding to that weight. And then you should have the ratio, double ratio. Okay. Which is value by weight. Okay. Once this is done, we would have definitely the constructor. Okay. So I should say public item, and I will just initialize my weight and then the value. So this dot weight equal to weight, this dot value equal to value, and then this dot ratio equal to ratio. Okay. Uh, or let's say we can also write in this way that what is actually the ratio? Let's do it. So it's nothing, it's just the value by weight. Okay. Now once it is done, I would have my main method, or I should rather build one function which would be the return type would be double, and I should say fractional knapsack. That's the function name, and it should have parameters like it should have two parameters which would be my item. Okay, this one, and it should have a array because we have to have a array of both weights and values correspondingly. So we would have that, and then the capacity a bag can maximum capacity a bag can hold up to. And then the very first thing with the help of comparator, I would be just sorting it out based on the ratio. So it would be items, oh, and then comparing double, which is just a method, and it would just happen based on my ratio. Okay, so I should write something in this way: item dot ratio dot reversed. I think we are good with this. And let's say I would have the resultant array, a resultant variable, which I could just write total profit. So initially it is zero point 0.0, and I'll just run a for loop in my items. So I would say item running in my items, scanning through the array. And here we actually have to check that capacity should not exceed the weight. Okay. So this is a scenario of adding the whole item to the knapsack. Okay. So I would be just adding, so two things I would be doing, adding the profit or adding the value to it. That's the first thing. And then subtracting the corresponding weight from the capacity. Because we really need to find out the remaining capacity after subtracting the corresponding weight. Okay. And then we would have this else, which would actually take the fraction of the item. So I would have double fraction equal to double, uh, it would be item dot value by weight, of course, item dot weight. And then again the same thing I would be repeating, but here with the one small change I would be multiplying my remaining capacity. So it would be fraction into my capacity. And then my entire capacity after doing all of these two, definitely my capacity, I'll not left with any of the capacity, so it would be turning out to be 0. I'll just write it up, and at this point of time only I should terminate the loop as the knapsack is full, of course, or I should say the bag is full, maximum profit has been achieved. And then whatever the total profit I have earned out of it, it's the time to return that. That's done. And then I think I should have my main method for testing. Let's do that. Public static void main string args. And let's say I do have a capacity of 50, and I'll just add my items weights and values. So I would have new item. So let's say weight is 10 and the corresponding value is 60. Same manner I would be doing it for my rest of this. I should have 4 items, so I would be just breaking it, copying this piece in 4 times. Yeah. So first time it is 10 60. Next time it should be 40 40, and then 20 100. Let's say, and then 30 120. Now I would just call my function, which is this fractional knapsack, and I'll store it inside one variable, which could be double max, or yeah, double max profit equal to this one. And I'll just pass my capacity, and then maximum, sorry, items, which is nothing else, my array. And then system dot out dot printf. So up to 2 decimal places I would like to print. It would be max profit. I think that should work. Let's see. Execute. I'll just make it public. Okay, I will just pick up another one again to run this. Okay, so many mistakes, of course. This should have. Items equal to new item times 60. This should be. Iris dot sort items, comma, comparator, not comparing double, item, and then item dot ratio dot reversed. I think there is no mistake. Okay, I have written a mistake over here. It should be comparing. Yeah, that's my answer. 240. As per the logic which I have written, so two cases I've handled. First one, considering the whole case, and the next one is by taking the fraction of it. I think that's all for this video. Hope you have understood well. Thank you for your time.